Welcome to All Things Engineering by EIT. This is a podcast where we cover industry insights, emerging trends, and practical knowledge across engineering disciplines.
Hello, everybody, and welcome to our podcast series. And very excited to have you all here. Today's podcast title is Industry 4.0, Redefining the Engineering Landscape. And I'm really excited to welcome Abdulrahman Shaalan, our very own Abdul Shaalan. And I wanted to just ask if you wouldn't mind a really quick introduction to yourself, Abdul.
Yeah, thanks, David, for inviting us for this talk. So I'm Abdul Shaalan. I'm an Industrial Automation Program Leader at ACT. My background is mechatronics engineering towards engineering management, towards advanced maintenance practices of modern manufacturing assets and in the advances of Industry 4. I was a lecturer at Sunderland University, led a couple of programs, electrical and masters, did teach across different levels, undergrad, postgrad degree apprentices, did carry out some industry work with different industries, food industry, aerospace, automotive, within automation systems and maintenance practices.
Brilliant. And so in summary, I think it's fair to say that you are an expert voice on automation, robotics, and digital transformation, and many other things, no doubt. And so just from our perspective, especially when it comes to automation, industrial automation, and associated disciplines, we obviously see quite a lot of demand globally. And I think we'll talk about it a little bit in this podcast, but just in terms of the trends for education in this space, I think there's a lot of demand. Certainly maybe possibly a lack of engineers in this space, in automation, probably other areas too. But we're seeing certainly on our side a lot of students on these programs. Just wondering if you have any insights into, perhaps some of the reasons why we have a lack of automation engineers in this space. Perhaps something to do with other emerging industries, or maybe lack of understanding of automation. What do you think about that?
So I'll give you what I have seen over the years, really. So we used to hold forums, and I've been to many conferences, and we used to talk to industry reps and within the companies that we actually did work with as well. So one of the big issues you see at the moment is the changing in mentality of people. So no one wants to work in a factory anymore. No one wants to do this repetitive, dirty jobs, let's say. And we've seen many companies which stop production lines because they don't have people to work. And it's a big issue. And that's why you will see that a lot of companies would actually leave the UK or leave certain parts of the country and go to more of development countries where people would accept or want to work in factories. And this is where automation comes handy, because this is where you start to see that, well, I can automate these repetitive tasks. I can get a machine to do that task, and this machine is going to be more efficient. It's not going to take wages. It's not going to go on the sick. It's going to make really high quality products. It's going to increase my capacity, all the good stuff. So that's why industrial automation became a very good or a very needed aspect in the manufacturing industry now, because, well, you can find people and you want better products and more products, and this is the benefits of industrial automation.
There's a lot of interesting facts to unpack there, and I'm going to talk a little bit more about sort of the scarcity of particularly automation engineers from our perspective, traveling and to different countries in the world where there are absolutely big risks in businesses where there's a lack of engineers, and some of the reasons there. And I guess we're actually in an era where, like you said, where machines don't just work, they think, communicate, and make decisions. Just wondering out of that change, what that change means to an engineer today. And I think it's probably the age-old thing: will machines take our jobs? So what does that mean? I guess what does it mean for engineers today with the evolving technologies in automation?
So Well, the idea of a machine having decisions and correcting itself and all of this is still ideas in progress. It's not embedded within the manufacturing industry to that extent. Maybe with big companies, the big names that we all hear about. But to give you a very basic example, when you are working with, let's say, a car manufacturer, a Nissan, which we have here. So one factory, one big factory, but it is working with more than 200 small factories. And these small factories don't have that intelligence. They don't have that advancements, but these are the workhorses for the industry. These are the ones that actually get the people to work and have jobs for the people. So when you start to think about, right, what's all of these smart and readjusting stuff, that's not the focus. The focus on Industry 4 and what it brings to the table are different aspects, really. So we talk about industrial automation. And industrial automation, this is something that I mentioned to you before. It is something from the 60s. It's not something new to have an automated system. It came with the birth of computers, really. So that's not really something new. But Industry 4 came around to overcome some of the issues of industrial automation. And this is what each industrial revolution really came around to do. First revolution, we started to use tools, but it's what the problem was. We are using our main power. Industry 2, right, let's start to use steam power. Now we started to use external power source. Industry 3, we started to have some intelligence and this computing power in the 60s. But the problem with automation was isolation and the many problems that might happen within the system. Each machine is working by itself. I'll give you an example happened at Nissan here, where we were working a few years back. So have a big automated production line that makes the cars. One part of this factory is the paint shop. And because it was still the old normal industrial automation systems, so each part is isolated, a problem happened within the paint shop. So the humidity and the temperature within the paint shop wasn't as it should be. So at the end of the line, they started to see rainbow colors on the cars. So no one knew about it because the problem was at the machine level, but there was no one next to the machine to know that this problem happened now to stop the line and start to fix it. So you can start to think that how many cars have been produced with this rainbow colors until they started to find out the problem. This is where Industry 4 comes around. It connects all of these systems together. So you can have a big arching system that can, there is a problem at the start of the line, which is a mile away for big factory, and we can stop and start to tackle it and save a lot of money based on this connectivity and all of this. We have the terminology of Industry 4, different technologies, an AI and cyber-physical system, but go down to the actual industry, to the workforce, the workhorse of the factories or the manufacturing industry. They need that connectivity. So, and that's why I wanted maybe to show you some of the stuff we have here. So, we have a PLC. So that's a normal PLC. Well, welcome to the 60s. Fine, we can program it. We can make an automated machine. But the problem with this is that it is an isolated system. So if anything happened and I'm not next to it, I will not know until I find at the quality check later on that, well, it is making bad parts. So you can see that you lost a lot of money making bad components or bad products. The next problem was, well, this is a sensor. And that sensor is wired to this PLC. You can see that it has 3 wires. So and instantly you can start to think, right, any of these 3 wires can be damaged. And if it got damaged, it's not going to give me correct representation of what is going on. So what can I do? And this is what Industry 4 came around. Many technologies were not really that recent, but they started to come together under one system. So instead of having that one sensor that is all the wires and all the calibration that must happen, we started to have smart sensors. So this is an example of a smart sensor that is just plug and play. So I will plug it to that brain, small brain, and that's it. I don't need to wire anything. I don't need to calibrate anything. It understands automatically. Well, happy days. So now we did overcome this issue. We started to have connectivity, as I said. So this PLC now can connect to a network, and we have something like this. It's another smart sensor, wireless sensor that can stream multiple points of data, temperature, humidity, elevation, pressure, whatever it is. Very handy in manufacturing. Stick it on many machines and it will give you really good insights. So this is kind of a wireless version of it. And this is another one for condition monitoring. My area is maintenance. How can we monitor the different conditions of machines by sticking one of those on the top of it? We're not going to get into the fact why it's not connected to PLCs, but it's one of these things. And all of this now is connected under a network. And now we have a big brain, a gateway. And it's like how you mentioned, like from its name, the gateway to everything. So it can talk to everything. It can talk to a PLC, to a smart sensor, to wireless, different languages. The Google translator of connectivity between machines. And all of this can be accessed from everywhere. So these are the things that industry are interested at. AI and data analytics, and this can be done in different things, forecasting and whatever, but this is the power of Industry 4 that people or manufacturing sector need really to know about.
Incredible. And you've touched on sort of how Industry 4.0 differs from earlier revolutions, and some really good practical examples, also some practical examples of that production line all the way from the beginning to the end. And I was just thinking about the role of people in it all. And so there's so many different areas where you need those people, real life human beings, to sort of be part of the process, even to sell the rainbow colored cars, because you need to recover your cost. And I was thinking that can be done too. So that's really, really fascinating. And I think employers they're looking for and probably paying a premium for highly skilled, would say, digital engineers with more than one skill. And I think the landscape's changed in employment, certainly from our perspective, and perhaps for the viewers today. Just to reiterate sort of what I do for EIT and ECT, I spend a lot of time traveling different countries in the world and interacting with our various teams. And one thing that's important for me to do is always have conversations with people on the ground, from technicians to technologists to engineers and everyone in between, to find out what's happening in the industry, what education trends are emerging, some challenges of the employers, and what our goal is to make or to give a student the absolute best shot to be relevant in industry and to be employable, whether that's students that study on campus with us or online around the world in 142 countries. And so I see a lot of everybody always talks about the need for cross-disciplinary skills, and so you cannot stay stagnant. Abdu, what do you think about that?
Definitely. Well, it's the modern manufacturing industry. When you look at a machine, the old school machine, it's just a mechanical and electrical pure system. But now you have multiple integrated systems in order to create that fully automated machines. So I was working with a company that makes slushies, the ones that you get from the supermarket or whatever.
Yeah, delicious.
Yeah, I loved it when I went there. I was always having some of it. So one of the machines that was fully automated production line, looking at the machines themselves, you start to see how everything is integrated together in order to make this product. One machine has the electric elements, has the mechanical elements, has the hydraulics and pneumatics elements, the control and automation elements, and the different ones from the heating and sterilization elements. All of these are different systems are integrating together, and they have to work together, and they have to work perfectly together. So if you have one skill, that's not enough to fix one machine or to run a production line or a single machine in a production line, because of all the integration. So future engineers must know about everything. Even if you are not that in-depth, very highly specialized in one area, but you must know if you have an issue, where this issue is coming from, so at least you can refer to that person that can fix it. But as a starting point, you must know about everything. You must know about mechanical, electrical, control, pneumatics, hydraulics. These are basic knowledges for modern manufacturing systems. Without them, you're just back in time.
Absolutely. And, I think we perhaps chatted about this. We spoke about this yesterday a little bit in our conference that we had. And I think there's so many other things more than technical to be, important to actually be able to communicate and to write clearly and to understand financial implications, I think is really important too. And it just shows you how rapidly the world is evolving and we never know what's next. And I think, certainly from our perspective and, talking to people, there's a massive shortage of automation engineers. And I think there's various reasons for that, possibly, other emerging areas in engineering, perhaps more, I would say, attractive to some people, and maybe some other reasons. And I think there's definitely seems to be quite a shortage of automation engineers. And some of the problems that we could anticipate from that, or is happening, is probably bottleneck on projects, delays, and all that type of thing. What do you see? What do you see in the industry in terms of shortage of automation engineers? Do you see a problem?
It's a big problem. And well, back to that slushy example and many others, but we don't have the time for it. So that slushy example, the reason we went there because one of the machines broke down and there was no automation engineer to come and fix it. And they had to wait for someone to come from the US, and that took them 6 months to fix it. And many thousands, really, for that person that knows about the machine to come and do literally a couple of hours worth of work. That was it. No one to fix it. And the factory was upside down. They had to manually do that process for that machine within the production line, extra head cost, lack in production delivery, many issues. So you can get the machine, you can buy the machine from anywhere. You can buy it from China, you can buy it from anywhere. But how are you going to keep this machine running? And that is the problem. You can get it, how are you going to drive it? This machine should last for 20 years. It's like your car. You bought a Rolls-Royce. If your country or your place doesn't have a Rolls-Royce dealership, you will not even be able to change the oil. So it will break down. So this is the need for industrial automation engineers. You need them to keep these systems running. And you need them as well to start to bring these industries and these machines building industries home, because, well, at the moment, there is not much people that can build them. So if you started to upskill this, you start to cut the dependency on foreign countries and how they are
very expensive foreign countries. And absolutely. I wanted to, you've reminded me of a discussion that I've had with someone actually quite a few people. And so we traveled to Mauritius not so long ago, a few months back, and I was discussing this particular issue with someone that has connections in the brewing space. So they're one of the automation engineers at the brewery. And he was just saying that there's one automation engineer keeping everything running, and they just can't find the right people. And I think brain drain is another massive issue we see in developing countries where students are highly qualified, brilliant students. And we're lucky we have students all over the world. As I mentioned, we've got students all throughout Africa, Middle East, Australia, you name it. And so when we travel and we talk to students and we have events all over the world, one of the big things is the brain drain. And so the ability to recruit talented engineers is really difficult because they're just not there. And so there was one massive plant operation with one automation engineer. Can you just imagine if something happens to that person, a massive operation sort of not running? Similar in Botswana at a big multinational soft drink company, same thing. And I think, the ability to attract talent, but to keep it is quite challenging. I suspect companies will be competing for these individuals in these types of markets and be paying them a lot of money, actually then driving up the cost of the operation. So I think it's a massive thing, a big shortage, and I think a massive opportunity for employment for people that are looking for this to enter the space, I believe.
You started to see what is happening around in the global landscape at the minute. What you can see is you can start to see a shift from the old centralization, that there are certain parts of the world that are making certain things, into decentralization. Everyone started to realize now, I have to make everything for myself to cut these dependencies on someone else that might control me. So that is the core element. And this is one of the issues that happened with the UK. It started to go back, it started to be very much a decentralized country, that, well, we're going to focus on certain elements of the different industries. And from the manufacturing industry, it started to die a little bit. It started to rely on different places, different countries for technology. But now they started to realize that, well, that's not going to work. We cannot, especially with COVID as well, when we started to have the restrictions, we couldn't get any controllers, for example. You have to wait for month and month in order to get parts, to get anything. So now the realization and the new direction for different countries is decentralization. How can I make everything at home? How can I have all the different expertise? And industrial automation is a very needed experience. Not much people that knows about it, and they're very highly paid engineers. It's more than doctors now at the minute. So when you get them, you have to treat them like royals. So it is a really demanded expertise. And all the different industrial companies or manufacturing industry started to realize this, started to adapt it, started to work on it. And you can see this with the upskilling initiatives with different companies that need, or they're putting their employees towards these different courses in order to help with these systems.
Abdul, I wanted to just shift to a little bit of we spoke about this and a little bit, and in terms of the changing engineering landscape, we've seen a shift from traditional mechanical, electrical roles to mechatronics, robotics, and data-driven engineering. The rise of interdisciplinary engineering, and we spoke about that, software meets hardware, and then also, again, how Industry 4.0 impacts sectors like energies, transport, food production, and mining, and also the growing need for lifelong learning and upskilling. And I guess, again, what new skills do engineers need to stay relevant in the smart, automated world? We always said stay curious. Keep talking about that. So taking all those things into mind, I guess, what advice do you have for our listeners to stay relevant, employable, and ahead of the curve in this automated world we live in?
So mainly with the recent technologies and AI and all of this, what I would say is stay up to date. You have to learn programming. Well, I'm not asking you to be the top best programmer in the world, but know how the programming works. Know how a system should be programmed to work. Then you can use ChatGPT to make you a really nice code afterwards. But if you don't even have the knowledge of how this works, you will not be relevant. So it's all about learning the concepts and learning, let's say, the 101 of each element, and be relevant and be open to change and think about how these technologies can benefit my workplace. When I was teaching the degree apprenticeships, because all of them are working, so all of my assessments were based on their jobs. So I would give them an assessment. I would tell them, right, your assessment is based on your workplace. Go back to your workplace. I did teach you new technologies. I did give you the knowledge. Well, this exists now. Go back to your work and start to think, how could this impact your job? How could it improve it? And how can you adapt it to your job? So I'm not asking you to do it. I didn't give you the deep skills to be that very much highly skilled person that are going to do it now, but be open to the idea that these technologies can be adapted. But how can it be adapted? Go and give me a plan for how can you adapt it. Well, maybe later on you can get a specialized person to do X and Y and Z, but that openness to know how this piece of technology can be adapted and how can you plan for that adaptation, manage that adaptation, is a very needed skills. You can see that many of the inventions came from great people and never seen the light. And that's because that person did not know how to adapt it, did not know what the market needs exactly and how this amazing piece of technology can be used and can be adapted and can be integrated. Know how to develop your soft skills, know how to embed systems and do changes and apply changes to where you work or where anything that happens. So yeah, nothing specific, no specific piece of knowledge. Well, go and learn Python and that's forever. No, that's dying now. ChatGPT would make always better code than yours, but know how can you integrate it? Know how could this benefit you, and how can you make a nice plan for that transition and adaptation of technology?
Absolutely. And Abdul, I think also another stay curious is exactly what you've basically succinctly described there. And also from Sue yesterday saying just don't be deterred by small failures or big failures, opportunity to look for another path to where you wanted to go to. I think that's important. Resilience is really important in every place of life, but certainly for an engineer, even more so. And then, understanding the value you're adding in the greater scheme of things and within the project. And, that probably from start to finish, where you're adding your value. And I think understanding that will also drive your curiosity and your resilience. And when it comes to education and skills development, how does automation engineering programs, they're obviously adapting. Can you talk a little bit about the need for partnership with industry as education and skills development sort of develop, and they're rapidly doing so? Just a little bit about the importance with project-based learning, partnership with industries, and some of the technologies that are used and how it's maybe more relevant for people academics and students to be involved in industry.
So if I'm getting your question right, I would say that, and this is something that we are working on at ACT, as well, it is an online education, so how can I stay relevant? How can I apply this? So we are relying on actual case studies and links to industry, putting students into trainings and internships at certain times with companies, so they can do like how I just mentioned with the degree apprentices. How can you be relevant? How can you apply this somewhere? So as I said, it's all about, I'm not going to give you the whole knowledge. I'm not going to give you everything. And if you couldn't see how could it be applied, if you didn't go to the shop floor and see, yeah, my teacher told me this, and it can actually be embedded here and there. If you didn't go and have this industrial engagement, you will not be that much relevant, really. So this is something that we are focused on and trying to adapt and see whatever we teach can be tangible to industry, get the industry to show us or to showcase what they're doing. So it's all about this relevance and links. Academia without industry is nothing. So it is back and forth relationship. And this is something we appreciate, and we want to nurture very much. So it's all about that link and creating that adaptation and the relevance between industry and academia.
I think it's important, Abdu, from our perspective as a student recruitment manager, talking to industry, as I mentioned before, we do a lot of events globally, and we meet a lot of students that perhaps have come from another institution and they're just keen on upskilling themselves. We do CPD courses, we do everything from that to adaptive engineering all through the line. And I'll get a lot of questions and comments from students that have studied at perhaps another institution. And it does happen where they say a lot of the times they're now in industry, or they're in their graduate engineering program at a company, or they're still looking for an opportunity, and they are saying that what they've studied is not current in industry. The technologies, the equipment that they learned, or the processes and procedures they learned, some are still manual in their programs that they're studying. And a lot of the times, more than I thought, and certainly much more than I'd like to see, students are saying, I haven't studied something that is relevant today, and I've just finished my program. I'm worried. That's a huge worry for me, and naturally, I think it just shows you the relevance of making sure your programs are relevant for industry, up to date. What you see is what you get, and that's something that we absolutely focus on here at Engineering Institute of Technology and Engineering College of Technology, our UK sister college, and it's quite disturbing. So we find students coming to us to refresh their knowledge. We find students coming to us. Sometimes they even retired, Abdu, which is incredible because they want to stay up to date with the latest technologies, platforms, and our virtual and simulated software. And I think it's wonderful. But that's something that's very important. I think if you keep your finger on the pulse with industry, you know what they want, and you're producing relevant, up to date, qualified engineers for the field, and that I think is our duty. It's definitely our duty to do right by the students. And another thing that we find, and for instance, our on-campus students that come to us from other countries, domestically in Australia, we similar to what I've said about students coming and saying, I haven't what I've studied, I think I wasted my time. I want to do a course with you to stay relevant. And similarly to that, we find students that study on campus with us. We offer internships to the students, guaranteed. They're studying on campus, Bachelor of Science in Electrical, Automation, Mechanical, Civil and Structural, Masters in the same discipline. We provide internships to our students. And again, at events that I go to, graduates from other universities come and say, I see on your brochure you offer internships. Can you help? And we're not in the business of providing, internships as a commercial item. We provide it to our students because it's very important you get access or you get exposure to industry. And so we're finding that seems to be an issue where students they're not getting that exposure to industry, and they need to have that. Just in terms of that, something we're passionate about, and so I have spoken a bit long about it, but it's so important. I think it's our job to make students employable. In terms of that, Abdu, I don't know if you had something to add to that before I just talked a little bit about the nature of global mobility for students.
About what again? Sorry.
No, I just wanted to know if you had any comments about that, but I wanted to perhaps move on to the what are students looking for, and I mentioned that they tell us what they're looking for, and we also know that they're looking for employability and hands-on learning and innovative ecosystems, and I think engineers want hands-on experience, right?
I'll tell you what the current problem with the UK education at the minute. The problem is that you would get students. I've been to many recruitment events. I've been to many colleges and schools. The problem what you get there is that you would get old school engineers that are teaching old school engineering. So I was really interested and had many chats with many different students, and I told them, right, well, what do you want to study? And mainly what they would say, well, I want to study mechanical engineering. Right? Okay. Why do you want to study mechanical engineering? Because, well, I did study it, and my teacher was giving me all the different things and concepts about mechanical engineering. So it's awareness. So that person doesn't really know that there is something else that should be looked at. And that was actually one of the core issues that we found across many, many places. Old school engineers don't really know much about automation and modern technologies. At the university or at ECT or EIT, our job as researchers is to really tap on what is coming out. We know we know, like I did my PhD 7 years ago, and I knew all about Industry 4, and I was doing Industry 4 applications when almost no one really knew what is Industry 4. So that's our job as a higher education teachers. So we have to know what are the recent technologies, and this is what we have to put the students and our learners in front of. old school engineering is not that much relevant anymore. So what I would say is it's all about, our job is to give you the recent technologies and to give you the recent needs for the markets, because this is what we do. We're not just teachers that are just making lectures. Making lectures and delivering lectures is a small part of our job. Big part is researching into the new trends. Big parts is working with industry. Big parts is try and fail and try again until we get to that sweet spot to know, well, this works, so my students should know about this. My students knew about IoT 5 years ago, before COVID. I was teaching my students IoT and all of this, and that was fine because we knew about it when no one else really knew about what we're really talking about. So that's the powerful of what we do. Our job is to make you relevant and to keep you up to date and to show you how industry works and to connect you with industry to know how or what we are teaching you is relevant and can be applied and linked, to give you the technical knowledge and to give you the soft knowledge and the soft skills that you would need in order to be able to communicate with people. So yeah, I hope that makes sense, really.
Absolutely does. And thanks very much for that. I wanted to just touch on global mobility. Now, we know technology can connect you anywhere. And I think it's important for our listeners, our viewers, just to, if we touch base on global mobility, and I think if you maybe just 1 or 2 examples from you, but in terms of automation engineers, you can work from anywhere in the world, and you can control equipment in a remote mine site in the middle of a mining site in Western Australia from your office in Johannesburg or in Cairo or in wherever you are in the world. And I think it's incredible. So in terms of global mobility, you can work anywhere in the world, really, naturally, because of shortage of automation engineers globally, and there's a dire shortage. But also, when you talk about global mobility, you also talk about accreditation. And so, accreditation of programs is important. And if we look at our Engineering Institute of Technology diplomas, bachelor's, and master degrees, got something called the Dublin, the Sydney, and the Washington Accord. So not only can you practically work around the world in terms of the nature of your job, but also gives you the accreditation under those accords for our automation programs, allow you to register with many different engineering bodies. And I think that's really relevant and it's very good. So I encourage our listeners to do a little bit of research into the Dublin Accord, the Sydney Accord, and the Washington Accord to look at all the signatories and what that means. But in terms of the shortage of engineers and the nature of your work, you can work anywhere in the world. It's incredible. And then, Abdu, what is the importance of diversity and international collaboration in engineering? Something I love. I'm so passionate about international collaboration. Can we learn something from different engineering teams across the world? What's your thoughts on that?
What you would see, as I said earlier, we are living in a centralized economy or centralized world at the minute. So where you would see that one find different places have different sets of expertise. Within the manufacturing systems, for example, in Europe, what you'll see certain machines, let's say, related to the food industry. Well, best ones are coming from Italy, right? So, well, machining machines, for example, where is it coming from? Our best ones are coming from the US. We have the Haas. You will see that different places are making or really good in different sets of expertise or different processes within the automation sector. Within the UK, you'll see that, we're really good within the health sciences machineries. So all the medical equipments, let's say. And that's why, as I showed you before, that little unicorn we had. So really heavy on investments and research on health science and health sciences. And this is the idea of collaboration and how can you learn from different places. If you want to learn about control itself, well, you have Germany. Well, the top controls of the world. If you want to know about robotics, you have ABB, go to Sweden. So you can see now every country is specialized in a certain aspect of automation. And that's the whole idea about automation systems and collaboration. And when you ask me about, well, what sets of knowledge should I know? Well, you should know about everything to start with, but you can specialize, and this is the next level. Well, I want to specialize in robots and cobots. Well, we have ABB, as I said, and you have different ones. You can start to target or tackle or focus on different places and different areas, but it is needed anyway and everywhere. And machining, as I said, well, you have the US, health sciences, you have the UK and Germany as well. Control systems themselves and pneumatics and hydraulics and actuators, Germany. So food industry, as I said, and the packaging and all of these different specific industries, as I said, you have Italy. Metallurgical, you start maybe to shift a little bit into Korea and Japan. So globalization, as I said, we are centralized economy at the minute. Everyone's trying to get into decentralization. It's not going to happen anytime soon, but that's the new direction. But you have to know about everything so you can start to look into the different systems you want to work with. It's similar to what you have with IT. Well, start with when you are a computer science student, you have to learn everything. You have to learn the basic about databases, the front end, back end, data analysis, all of these different things. But later on, you can be a specialized back-end developer that makes the engine. You start to be a games developer that makes games. You can be whatever you want to be. So learn about everything, and then you start to tackle where everything is really focused on, and you'll find what you want. But it's all about this global. You cannot really be locked into where you are. It's all about collaboration between different places. I have really good colleagues and friends from ABB that we have chats with all the time, go to conferences. And they keep me up to date with what's going on. I have friends from Germany and the Industry 4 elements and what they are making. And I have friends from the US and the different systems. It's all about this. It's all about stay connected, stay relevant, and be open to different places, because everywhere has its own strength in a certain aspect of the automation systems.
Wonderful. And I wanted to ask you another question, just in terms of the future. Do you have any predictions for the next wave, Industry 5.0, with regards to human-centric, sustainable automation? Any other insights into the next wave?
So it's well, now we are living in Industry 5. Now there are talks about Industry 6 and 7 and Industry 100 are coming. It's going to come across soon. So all of these waves, as I said, every industry is coming to tackle an issue happened or was found out by the previous one. So Industry 4 came around to tackle the different issues I just showed you at the start about the connectivity and about how everything can be more efficient and all of this. Industry 5, because Industry 4 now focused on technology and that's it, we don't want to do anything else, we started to forget about people and how people can actually work together and be relevant and interact with this technology. And that is the human-centric application or the human focus of Industry 5. Well, we got all of these technologies, so what are we going to do about it? And this is when you start to look at people. And, well, I need some sets of skills, really, to run this machine. Well, I have an airplane. Well, do I have a pilot license? Well, now I start to look into it. So that is the whole idea. And that's what we actually, as education institutions, this is what we do, Industry 5. So we're looking at the human-centric or the human aspect of technology. We're not teaching new technology, rather than we start to look into, well, this is how you deal with technology, and this is how you stay relevant. Many people started to look at, oh, well, automation systems, it's putting people out of jobs. No, it is upskilling people. It is making people more knowledgeable, more relevant, and making more money. And their job is not as boring anymore, that I'm just doing the exact same repetitive task anymore. Now you're doing something different and more exciting and making way more money. So yeah, actually, as education institutions, our job is Industry 5. Our job is to look at the people and how these people can work with technology.
Incredible. And just how quickly things evolve and how fast that is just sometimes it's incredible. And like you said, lifelong learning, that's an engineer's job. also in academics like yourself. We speak about AI quite a lot, and I guess a lot of people are maybe concerned. I'm not quite sure, but should we be embracing artificial intelligence? And what role does it play? That and also ethics in engineering. Would you, or would you summarize that? What role does AI play in engineering? And you can combine ethics with that as well. Can AI solve all of our problems in engineering? Do we need engineers?
Good news about the new revolution of AIs. Engineers are safe so far because I was looking at, there was a TED talk before, and I forgot the name of the guy, not at the top of my head at the minute, but the more relevant jobs that you will find or you will still keep are the physical jobs. So if you are a plumber, well, you're super safe, man. That's absolutely fine. But everything that can be done on the PC and everything that is not actually having physical elements in it started to phase out because AI is doing it way better than what you can do. So programming, we can see the impact on programming. We can start to see the impact. They published a list last week, really, in the UK, or earlier this week, about what are the most jobs at risk of AI, like translation. So all of these interpreters now, well, you're not going to be much relevant in the future. So whatever you can do in a computer, AI is going to do it better than you soon. So engineers are very safe. Now it's still physical. You still connect systems. You still build stuff. If it is an automation system, yeah, well, you have the PLC and you have the sensors and all of this, but well, you still have to wire them. You still have to make sure that it is calibrated and working how it should. AI can help you in the design phase and the basic elements of basic programming structure, for example, but you still have to put in and tweak however you want based on your physical system. You start to have that, you start to see that, well, it is a really good thing that I'm an engineer, because if I am a computer science and they did jump on the wave like everyone did in the last decades, I would have been really not in a really good position at the minute. So it's all about AI is good. It can help reduce the workload a lot because there are different things that are just repetitive. And the start of building a system, let's say, the skeleton, the flow, and whatever. Yeah, these stuff AI can help with, and it's going to reduce the time spent in doing all of these different things. But you as an engineer, you're still the brain, and you're still the workforce, and you're still the one that puts everything together. And as an automation system engineer, because AI cannot see really what's happening in the physical world, might do, but you're still the one that's going to do it and calibrate it and see if it is working how it should or not. Can embrace it, and you should embrace it. You should use it to make your job more efficient, more easier. But yeah, it is still very useful tools to be used, and it's not going to be any risk for engineers anytime soon. Well, until they make very smart humanoids, and it's something that's still very far ahead from where we are at the minute.
And so I agree with you. Should embrace the technologies, and I think maybe perhaps, and I could be completely wrong, and I defer to your expertise there. But so basically, a very capable personal assistant that can reduce your repetitive tasks, but we need to check what it does. And obviously, us as human beings, we are creative thinkers. We can come up with new ideas. I guess artificial intelligence just basically synthesizing information that exists out there in the world, right?
Well, it's AI. Just when did the ChatGPT came around? 2 years ago now, wasn't it? Almost more or less. We're still in the very early stages of it. We're gonna get into the super intelligence level very soon. Within the 5 years, you're gonna have really smart AI that doesn't really need you to review what it is doing. And that's a fact. I'm not saying that, we still need me as a person to review what you do so I can keep myself relevant. It's going to be better, and it's going to be way better than how it is now. Something that came out 2 years ago and doing what it is doing now, within 5 to 10 years, it's going to be way better than us. But as I said, it is all the digital aspects of things. As an engineer, you still have to know how to put all of these things together. You can embrace it. in the future, you will not really need from all of the things that you keep hearing in the different forums and the different new trends. It's going to be very intelligent that doesn't really need you to review whatever it is doing. You can really trust it. But as an engineer, you're still physical. You're still putting systems together. You're still looking at the big picture of how that technology or the software's aspects or whatever it is coming from the digital device, your PC, is going to be integrated with that physical element. And that is the power of automation systems. You're building systems, physical systems, that are intelligently controlled. AI is going to be really good in doing that digital part for you or with you, but you're still relevant in putting everything together.
Incredible. And I wanted to, you have provided very safe, very good, relevant advice to students, but I just wanted to close off this section and just say, is there anything else you would advise students and young professionals entering this world that could seem a bit intimidating based on all the rapid changes?
As I said, be open to change. Think about how all the new trends and new technologies can be adapted, and learn soft skills. Learn how to deal with people. Learn how can you get everyone around the table, and how can you get the different expertise together, and each person can do their own tasks and own job, including you. So as a person, you will not do everything by yourself. If you say that, well, I can build the whole thing myself, no, you can't. If it is just a control system, well, you have a control panel builder and you have a programmer. So even for just the control system, the control panel of a system, not a single person can do it on their own. So, but you have to know about everything. You have to know that this control panel, for example, need to have certain criteria and have to follow certain ISO standards in how it is built. You're not going to build it. You're not that much experienced, licensed, whatever it is, but you are the programmer. You know that the machine itself must have certain pneumatics, hydraulics, control, wiring, whatever standards, and this is how it should look like. You're not going to do it, but because you are the experienced, specialized programmer. So it's all about this. Know how can you embrace and integrate the new technologies and think about that integration, and know how can you work with other people and develop your soft skills and your small, short courses that you can tap on in order to develop these skills. These short courses are not going to make you the top-notch experienced person, but will make you aware of what is going on and how can you do it. And that is, this is my advice to the next generations.
Thank you, Dr. Shaalan. And I'll talk a little bit about, in wrapping up, because we offer some programs that will allow students, either number one, to continue their learning journey in the CBD space, but also formal qualifications. I do want to just talk a little bit about that, because as our viewers, you might be wondering, well, how can I get there? We've got different levels of courses, which I'll talk about in a minute. And I've got a closing quote here for this section. The future engineer isn't just a problem solver, they're a system thinker who designs smarter, safer, and more sustainable worlds, and that will continue. Just to wrap up, Abdul, I wanted to just recap a few of the key takeaways, and from our perspective, it is to, again, I've said many times, stay curious. There are many jobs in the automation space globally, and there's a shortage of jobs, so I think employability is a massive plus for those in the industry or considering entering the industry. And I believe in terms of, we've got a job report on the Engineering Institute of Technology website, where we've actually scraped many thousands of job adverts to see exactly what industry is looking for. There's incredible information on there. So check our website out, Engineering Institute of Technology, EIT.edu.au. We have a jobs report there, so we can allow industry to tell you what it is they're looking for and the types of jobs that are out there. You'll be very surprised. Please check that out and download that, and you will see exactly what employers are looking for and the types of salaries that you can earn. And other takeaways, Abdul, what would you, just 2 or 3 key takeaways from our session today for our viewers?
So Yeah, our session is really insightful. It gives really good idea and insights into what is going on. And it's not just to say, oh, well, it's marketing and whatever it is for the EIT or the ECT, but it is relevant, whether it was from the courses or whether it was from the CPD. I just recently joined the ECT. The reason behind it was because I know what it is offering is relevant, and it makes a difference. Uh, so it's yeah, I would really encourage anyone to look at the IT and what it offers. Same for us for the UK part of things, if it is relevant to the ACT, and even if it's not any of them, it's all about take that advice. It's an honest advice from people that are working with industry from global levels of companies. Oil and gas did work with on the biggest machine in the world for subsea cabling machines, down to the very baby machines and the food industry that makes juice and food. So from all of this, I would really suggest, encourage students that look into automation, look into these courses, electrical aspects, electric courses, small CPD courses, stay relevant, stay up to date. If it's not in-depth course, it's fine. You know the basics of it, better than watching YouTube videos made by someone that you didn't really know what that person is, and you think that now you know what you're doing. Yeah, accredited or not accredited, it's not about accreditation, rather than it's about how this is structured and how this is delivered. So we know as academics that this is how this course, the small course, should be. How we make that, give you that really reliable information. It's not a Wikipedia information that we are putting together on slides. We are really using very reliable resources to give you that really good structured small piece of knowledge. It's not the in-depth knowledge that is going to make you the astronaut, but it's a good piece of knowledge. Even if it is a little piece, it's a good piece. So yeah, I think that would be it. So yeah.
Fantastic. And I wanted to just, for the benefit of our viewers, we talk about EIT, we talk about ECT, Engineering Institute of Technology, our Australian provider, and then our newest member of the family, Engineering College of Technology. When we talk about courses, to those of you listening, please make sure that we're reviewing the information. We understand which course belongs to which institution. And if you have any questions, we've got a huge team that's ready to help you understand the difference between the two institutions. And just to wrap up, I'd like to just talk about those courses that we offer. So in both Engineering Institute of Technology and Engineering College of Technology, we have a wide range of automation courses. We start from professional certificates of competency. These are CPD courses that allow you to stay relevant. It's also a 3-month duration. So if you want to do something short to keep yourself upskilled and relevant in that area, or if it's something that you are curious about and you want to explore what is industrial automation, we have a number of professional certificates in that area. We also, on the Engineering Institute of Technology side, offer an advanced diploma of industrial automation, and that is accredited fully by Engineers Australia and under the Dublin Accord. We do have the Bachelor of Science in Industrial Automation, as well as the Master of Engineering in Industrial Automation. Now, in our Engineering College of Technology, we do have the Bachelor of Engineering Honours in Industrial Automation, the Master of Science in Industrial Automation. And so I would highly recommend you have a look at those courses, contact us, let's talk about it. And there are a number of other courses in that area in different disciplines that may interest you. Have a look, let's have a chat about that. Upskill yourself, keep curious, stay learning. And then also don't forget to have a look at our, keep your eyes open for our next episode of All Things Engineering. And we hope to see you guys. So also to our wonderful guest, Dr. Shaalan, thank you very much for your time and naturally your extremely valuable and very important insights into engineering and automation. We thank you very much.
welcome. Good to be part of this. Thank you.
Wonderful. Take care, everybody. Bye.
Thank you so much for tuning in today. If you enjoyed this episode, make sure to follow and subscribe, and so that you don't miss future conversations. We've got some exciting guests lined up and a lot more to share. So do connect with us on social media and share your thoughts, questions, or experiences. So until next time, stay curious and keep pushing boundaries. Thanks, everyone.